Unit 1, 1.5 measurements. This comes into the math portion of what Unit 1 used to be. We used to make this one big massive unit. Instead we split it up. So Unit 1.5 begins the process of adding some math to this. Some of you have already experienced many of this math in your math classes. As many of us don't really care to enjoy that word problems in math class, unfortunately the world is a world problem. And so we have to go through and figure out what is the problem telling us and trying to figure out ways, techniques to solve these problems. I like this three-step approach. You'll see it in our book that this is a similar approach, and we kind of have them there as keys to remind us of how do we do this, how do we part, and it's a 3 steps, and if you follow the 3 steps, you should ace the problem. Speaking of acing the problem, there's the pun and it was intended, and you have steps for solving numeric word problems: analyze, calculate, and evaluate. Not exactly all my original thought. Pearson Education had it out, and I liked the idea of you acing the problem: analyze, calculate, and evaluate. And so we use it. The analyze part, what do? We determine where you're starting from, figure out what you know and what you don't know. In some cases, what you know is pretty easy, but what you don't know sometimes can be tricky, and kind of knowing where you're going to go with that. If you have an expected answer when it says, what is blank? That's usually your unknown. Sometimes it has 2 parts to that. It's going to have a number part and a unit. And so you do have to pay attention to that. And we'll get into units and types of measurements and some of those things as we move forward. So then you make a plan for using what you know to solve for what you don't know. Calculations, this can be done setting up the problem, showing your equation that was used. In some cases, if you use the wrong equation, you're going to get the wrong answer. Sometimes you might be lucky enough to have the wrong equation but get the right answer, and so you get it right for the wrong reasons. But sometimes that happens, and that's just kind of luck. But so you have to be careful about this, and that's converting sometimes. And so we might have to convert a measurement. We might have to go through a calculation, meaning an equation. But a lot of the problems that we do later on in this class are converting, and there are some equations that we'll go through, but a lot of them have converting, and they have kind of a nice stepping process if you can figure out and know how to do a lot of those conversions. And then you have to evaluate. Does your answer look normal? If you can answer those things, does it make sense? Did I actually put everything into the equation correctly? Is the things as I put them through, do they make sense? Did I put it in my calculator correctly? Because I'm supposed to have this, really big number, and I got this really small number. Did I accidentally put a decimal in? Did I accidentally forget a decimal? Those are major, major things that happen so often, and that's why math teachers, science teachers always say, show your work, especially when we're beginning this learning process, that you show your work so that you have an opportunity to learn for where you went wrong. And that's why when we go through some of the examples, you'll see that. We have 2 types of kind of ways to express our numbers. There are qualitative, kind of tells us what's there, and then there's a quantitative, tells us how much is present. Qualitative is just kind of like, oh look, it passes the test. That doesn't mean that it's not there, or doesn't mean that a negative qualitative analysis doesn't mean that it's not there. It's just not there at a certain point. So quantitative, it tells us how much is actually present. And you will see this nice big chart. It's on the back of your periodic table that we use. A lot of them are based on the SI system or System International. Or some of them we will use some variation of them, meaning the metric system of them. Now, of these, we'll use length, mass, temperature, time, and amount of substance very frequently. And because we're using the metric system in this class, it will be necessary for us to convert. Ones that we will really definitely need to worry about in our conversions are kilo, that's a big one, centi, and milli. Every now and then we'll do micro, but only a small amount, such as micro is small. Now, micro looks a little bit weird. Its symbol is the Greek letter mu, which is, I always say it's a U with the tail in the front in some cases, as we look at that. And it's important to kind of note the bigger symbols are above your base units. So as we can see, our base units are seconds, meters, liters, and grams. If you have a kilogram, it's bigger than a gram. If you have a kiloliter, which is kind of an odd one, it's bigger than a meter. If you have a liter. If you have a kilosecond, weird way to measure, but possible. It's bigger than just a regular second, and so on and so forth. And kilo is also the only one that actually has a lowercase letter for being, even though it's bigger. And why that is will come in later. The smaller ones are below. How much smaller? Well, kind of sounds like a century, and therefore 100. Milli is not a million, as one would think, but it's 1,000. Tends to be the most common conversions that we end up doing. Now, exact numbers, and something that we'll look at a little bit later, again, kind of building process, kind of laying the foundation here. So we have exact numbers, numbers that have a defined value, such as 1,000 grams are in 1 kilogram, 1,000 milliliters are in 1 liter, 2.54 centimeters in 1 inch. These are your conversion factors, also, if you will. The inexact numbers, anything that you've measured, if you have measured it, it's not an exact number. You might say, well, I'm the best measurer ever. No, there's a reason why in shop class they say measure twice, cut once. It's very similar to that in chemistry class, where we have measure twice so that you only have to pour once and you don't have to restart a lab. We will use some scientific notation from time to time, and so we want to make sure that everybody understands what it looks like and kind of those types of things, especially when we deal with big numbers and really small numbers, because in chemistry we use really small particles, and so sometimes we will have to use scientific notation. For that, we have to make sure that we know what we're talking about. It's something that has been raised to the power of 10. And I use a number that we'll see fairly frequently in the coming units, and that is the 6.02 times 10 to the 23rd. You can write out all those zeros, but you know what? That's a lot of work, and it's a lot easier to say that it's 6.02 times 10 to the 23rd. And the coefficient of that number, you have the coefficient, the 6.02, power of 10, and an exponent of 23. And how you put that into your calculator is can be tricky for some, but you have to kind of be careful about it. You can do it without a calculator, and that's kind of how we try to go through this and show you how to do some things without a calculator. And so positive numbers mean that the decimal places move to the right. If there are zeros in the open spot, we put eggs in them. One thing we've used in years past is positive numbers are good things. You want to have a positive bank account. You want to have large amounts of money in your bank account, because why wouldn't it be a fun to have a whole bunch of money in your bank account? And so we have these large numbers are positive. Small numbers, we'll get to that in the next slide. So if we take our example here, and we move it 4 places. So I'm going to rewrite my 1.032, and I'm going to move my decimal place 4 places to the right. 1, 2, 3, and I need to fill a 4th. So that's where I'm going to put my decimal place. But I have to fill in my empty spot there with an egg, and then you get a 0. And so if I rewrite my number, I would actually have 1, 0, 3, 2, 0, which would be 10,320. Don't have a unit on it, but because we're just kind of getting used to this. And so that's what you would see and look at. Negative exponents mean that a decimal place is moved to the left, meaning you're dealing with really small numbers. And because we don't want to have really small numbers, fractions of a dollar in our bank account, that would be very negative. Nobody would want that. That's why we say if you see a negative exponent, that means it should be a small number, because small, negative, we don't want to have that. And so we'll do the same example here, is we'll write our 2.86, and I need to move my decimal place 3 places to the left. 1, 2, 3, and as I can see, I have 2 empty spots here, and I'll put my decimal place there. Now, whether or not you put a 0 in the front of the beginning part, in some cases it is technically correct to do this. It is technically correct to have that 0 there. Ultimately, quite arbitrary when it comes to entering in answers. For us, it's in some cases, so I'm not going to worry about it, but it is technically correct and should be there. But as you can see, we have a very small number, very much of a fraction. So if you had only 2.86 times 10 to the negative 3 dollars in your account, you would have a fraction of a penny. Now, going the other way, the reverse holds true. And this is what usually happens. But if I start with a big number, that's positive. That means I have a large amount in my account. And so if I start with a large amount and I move my decimal place over, and it's always 1 to be the front. And so you always want to have it a whole number of some sort. So a number of 1 to 9 is usually how it ends up being. And I can count my little loops underneath there, and I can see that my answer will be 2, I'll put a dot 9,836. And when we rewrite our numbers, we have to write all of those numbers because they were significant to us, as we see. And then I'm going to say times 10, and I moved it 3, 1, 2. We actually missed a loop inside there. 1, 2, 3, 4. Ooh, that got a little messy. But I'm 4 times, and so we can see that as 4. You can put a little plus in front of that, or you can just leave it as just a 4. And when we move it to the left, that means I'm going to take a small number and make it look big. And so we move again the decimal place 1, 2, 3. In this case, 4. And now we don't put it between the 6 and the 8. We put it between the 3 and the 6 because the 3 is a number between 1 and 9. And when I rewrite this, I can get rid of all those zeros, and then that's going to mean something to us in the next chapter. As we continue, we're going to see that it's 3.68 times 10, and I'd moved it to the right this time, and they should be negative because it's a really small number, and I moved it negative 4 places, or a negative amount, and so we have a small amount. So let's try some more out in this case here. And so we're going to see I have 5. That means my numbers are going to get really big. and I can go, if I go 6.82, if I move my decimal place 5 places, 1, 2, 3, 4, 5, fill it with eggs, and I will have 682,000. And the next one here, we're going to be moving it a different way. And I have my 3.10, and I see a negative, meaning I'm going to take it and go 1, 2, 3 places to the left, giving me 0. I'll give a better point in there. 0, 0, because I need to fill those eggs. 3, 1, 0. Now this one's a tricky one, and it usually bothers a lot of students when you see this, but why would they do this? Well, they have to play maybe around with something that is called significant digits, and so I just move it one place over, which is very odd, and it's something that we can use to our advantage, but it is what it is, and so it's just 20.6. And now here we go, the other one. I have a big number. That means my scientific notation should be positive. 1, 2, 3, 4. So my answer will be 1.234 times 10 to the, count my 1, 2, 3, 4. 4 spots. And here we have another one where we're going for a small number, meaning my number should be negative 1, 2, 3, 4. And so we have, get rid of all those zeros because they're going to be insignificant to us, as we will see later on. And so it'll be 6.12 times 10 to the negative 4th. And here I have a big number. Love to have this number in my bank account. 1, 2, 3, 4, 5, 6, 7. So I can go 1.03, and technically we should put these here. In some cases you'll see them, in some cases you won't. And I'll add to the 7th. In which of the following expressions is the number on the left not equal to the number on the right? Entering numbers on a scientific notation calculator, you can use the EE button. A lot of Texas Instruments will use an EE button very frequently, or they will use an EXP button. It is important that you have an ACT approved calculator. Well, it'll help you on the ACT a little bit. And it is important that you become familiar with how they are used. If you're not familiar with how to put it into your calculator, please see me. I have no problem. I love talking about calculators. So come by, see me, and we can talk about that. And it's important that you have your own so that you know how to use your calculator. When multiplying numbers, you can do it. Some people will just enter it in their calculator and it does all the thinking for you. But if you don't enter it in your calculator properly, you can go wrong real fast. And so kind of knowing what the calculator is saying is important. And so you have to speak to the calculator. And some people will be like, my calculator is giving me the wrong answer. Well, it might be user error in many cases, because the calculator's only going to give you the answer that you're telling it the problem. You're telling it the problem. And if you tell it the wrong problem, sorry, it happens by reading a map. And so you have these abilities. And so when you multiply, you add the exponents. You still multiply your coefficients, but you add the exponents. And so it's simple math, actually, and you can simplify the things. If you don't have a calculator, you can do it. You can take the ACT without a calculator. It's not always suggested, but it is possible. So it is important to kind of look at and say 3 times 2 is 6. Well, that's easy enough. Most students in second grade know that. And then you look at the 4 plus 2. Well, that's also 6. And so you have 6 times 10 to the 6th. And the same thing, if you have a negative number, you're just doing a little bit different of a math. So 3 plus a negative 7 is a negative 4. And so you can really simplify some of this stuff for you. When you're dividing, though, you have and subtract the exponents. And so you have something goes a little bit different. So to divide numbers written in scientific notation, divide the coefficients, as you normally would, and subtract the exponents. But now that means if you have a negative number, that means it becomes positive. And so you have to pay attention to the sign of that. And this is where maybe some people have lost some of their abilities to do some of the math in their head, but it is important, and that's what trying to tell you what the calculator actually is doing. As we can see, if you want to add or subtract numbers, you have to actually kind of get them on the same boat. 3 times 10 to the fourth, times 10 to the third, and times 10 to the second. As we can see here, they're not going to add up. You have to be careful, and things are not going to add up correctly because you're not changing how that works. So if you're adding or subtraction, you actually have to convert to make them the same exponent, and that can be a little bit tricky. And so as we kind of go through, it doesn't happen very often, and so it's not a major part, and that's why we're not spending a lot of time on it. But it is something that you should have already kind of gone through. It's something a lot of people use their calculator for, but we do go through it. So what does it look like? Well, the first one, we have a problem. So let's ace the problem, so to speak. So we're going to analyze and say, oh, I have a multiplying. That means I can just multiply 8 times 7. It's like, oh, I think I can do that. 8 times 7. What is that again? Oh, that's 56. But a negative 2 plus a negative 5, well, that would be a times 10 to the negative 7th. But if we look very closely and you put this in your calculator, you're going to actually get a different answer. And that's because you can do that. You can actually write out your answer as 5.6. And now since I made it positive, I need to add 1 to that. Well, if I add a positive 1 to a negative 7, that actually gives me a negative 6. And so there is a little bit of a difference in that, and we have to be very careful. And the next one, we have an addition or subtraction, and so we have to be, again, mindful of that. And so we have our 7.1 times 10 to the negative 2nd, and we're adding that to our 5 times 10 to the negative 3rd. And so we have to decide, which one do I go with? How do I do this? What's a negative 3rd? So that would make quite a difference. And so we have to be careful on how we enter this into our values here. And so this is a bigger number because it's less negative than this one. And if I want to change this as a negative 2, I'm going to put it in a negative 2. And so I'm going to change this to 0.0. I'm going to basically be moving another decimal place over. 5, 2, so that would be right. And so we go times 10 to the negative 2. And so if I kind of check myself and go 1, 2, well, that's where it would be. And so we can add them up together. And so I can add 7.1 plus 0.05, and that's going to give me a pretty small number there of 7.6, and that would be times 10 to the negative 2, because that's the same one. These two are both negative 2, and so that has to be the same part there. And so again, a little tricky. Can put it in your calculator. It might not always spit it out. In a case like this, if you put this into your calculator, it's not going to spit it out in scientific notation. And so if you didn't do that, you might have to know how to put it back into scientific notation. So regardless of how that works, it's a learning process. It's not going to be used a lot, but it will be kind of nice to have in your toolbox.